Friends, good evening, and I welcome each and everyone to this interactive session, this new series that Southern India Chamber jointly with SPCE has kickstarted, which we have christened as Peak. And this first session, we are launching with the session on 3D printing. Most of you would have known about Southern India Chamber. In any case, just a few words of introducing the chamber. The Southern India Chamber of Commerce and Industry, it's a 111-year-old industry body. When Mahatma Gandhi was fighting for the political independence of the nation, he had exhorted Sri Piti Tyagaraja Chettiar to fight for the economic independence of the country. So that's how SICI was born. And since then, it has been growing to champion the cause of the industry in several ways, several sectors, across several decades. Even today, we have over 25 focus areas spanning varied sectors like agriculture, food processing, automotive, electric vehicles, defense aerospace, and so many other key areas of interest. And SICI is also contributing to the knowledge economy through various reports and other surveys. We have a very good rapport with the government, both at the political leadership as well as at the bureaucratic level, at the state and the center. We also are involved in a lot of projects. So we are now setting up a reader's lounge at the Chennai Central Metro Station. We are trying to set up an electric vehicle center of excellence in Chennai. We are working to have Industry 4.0 center, hopefully down south. We are also trying to have a Mind Gym. We are trying to set up a startup exchange and multiple other projects as well. So we request all the members of the student community as well as the participants. We are here as a bridge between the government and the industry and the academia. So you are more than welcome to stay in touch with us, to connect with us, and utilize the services that the chamber is providing. Among the various sectoral focus that the chamber has, the employability task force, that's one of the active and dynamic grouping, which is chaired by Mr. George Koshi. So he has been working with the chamber, one of the chamber's long-standing well-wishers for over 10 years. So it is our pleasure to have this event put together. And at this juncture, I'd like to welcome each and every member of the panel. You have decided to invest your time and share your expertise. We welcome you and we thank you for helping the chamber deliver value to the student community as well. So this in short is something as a way of introduction to the chamber. And as we have a great feast of knowledge awaiting you, I don't want to take much of your time. And I would now like to request William, my colleague at the chamber, to introduce the speakers and kickstart the panel session. Over to you, William.
Thank you, sir. I now take this opportunity to introduce the panelist and the moderator. Mr. George Koshi, he's the Director, Learning and Development at SIFI Technology Limited. He's a leadership coach and has over 25 years of experience as a learning specialist in domain ranging from manufacturing, assessment centers, consulting, and information technology. He has previously worked in Infosys, Servion Global Solution, Hyundai Motors India Limited, and now he is currently heading the learning and development functions of SIFI, which is an informative communication technology company. His core expertise lies in leadership development, coaching, and learning practices. So Mr. George Koshi, he'll be moderating the session today. And we have the other panelist, Mr. Babu Ramachandran. He's a senior management professional with extensive experience in the manufacturing industry, in the automotive and railway sectors. And at present, he's self-employed and working on a social enterprise, startup, and management consulting firm. We welcome you to the panel, sir, today. And we have another panelist, Mr. Franklin Datti Elumalai. He's business head, Additive Manufacturing 3D printing, and he works with Premium Solution Private Limited. He has over a decade of experience in sales and business development in the automotive, railway, aerospace, and defense industries. He's now working on the new next generation technology, additive manufacturing, that is 3D printing, and has accumulated a significant amount of expertise. We welcome you also to the panel, sir. We have Mr. Irai Modi V, Head Healthcare at Sri Rapid Technologies. He's a mechanical engineer by profession and possesses a master's degree MS by research in additive manufacturing for medical applications. He is a professional with more than 10 years of experience in medical image processing, BioCAD modeling, and additive manufacturing. We welcome you also to the panel today, sir. I now hand over the session to Mr. George Koshi to take over the proceedings for today. Thank you.
Am I audible?
Yes, sir.
Yes.
Thank you. Thank you. And thank you, William, and thank you, Vinod, for introducing Siki and and ourselves and the panelists. So good evening all to all the participants here, all the student community. I'm sure that there are faculty members as well. Good evening all, and it's a great evening. I'm sure that we're going to discuss about the future of technology, and I'm sure that we have, like William was talking about, we have brilliant minds with us, and we're going to talk to them. And I'm quite eager and looking forward to this great discussion that we're going to have. And I was telling, I used to always say that I love talking about things that I don't know. That's exactly what I'm going to do today. I have no clue about 3D printing, and here I am going to talk about 3D printing. Advanced technology has led us into the future, and is taking us into territories I'm sure that we have not tread. One such invention is something which is 3D printing. Actually, when I was a kid, I used to look at awe when a dot matrix printer is printing, and I used to look at a kind of a surprise element, and a kind of it's amazing to see that dot matrix is printing on a paper, and how it's getting printed, and I'm sure that we have come a long way. We're talking about additive printing and stuff like that. So as I said, we have an amazing set of panelists. Believe me, two of them have immense expertise in the field of 3D printers. They are researching and also working on the same. And the other person that we have has great knowledge in engineering and digital transformation. And so like Vinod was saying, we are in for a treat here to hear from them. I'm actually as excited as you are to discuss on the amazing inventions, which is 3D printing. Okay, I'm not going to take a lot of time. Let's me go into the first question. And the first question is open to all. And generally, that's how I always pan out. It's better that each one of you can take probably 3 to 4 minutes and probably discuss, because the first question is quite open. I would like to nudge their passion towards technology specific to 3D printing, and probably you may say that when did each one of you generate the interest towards this technology? You may also talk about how you gained knowledge the first time, and when was the first time that you laid hands on the first 3D printer? Those are some of the things that you can talk about, the history of how you gained knowledge. Over to you, and anyone can take this question and probably pass it on. Thank you.
Okay. I would say, may I go first? Because other two gentlemen can speak.
Yes, there are no rules. There are no rules, Babu. Yes, you can go ahead.
So first of all, thank you, and great to see all of you. Okay, and I think very nice way which George put it. So I want to also, it is like an introduction how we got introduced to this technology. So I would also like to give a quick view. I think in all our engineering education, in whatever field we have been talking about the production technologies and figuring out how to build things. All right, and the very conventional terms of production of things is like casting or machining. You would find extrusion, injection molding. There are so many things which has been invented thanks to industrial revolutions. And along the progress of the industrial revolution, I think all mankind was trying to reduce the I would say reduce the pain of the effort, make it easier for people. Today we are in the sitting in the industrial revolution 4. It's right now happening around us, where we want to make it happen with with an automated or autonomous or even I call it automated technology, which means machines do a lot of things. The decisions, even a lot of decision processing is happening by the machines. So we are definitely on that. And this is where Industry 4.0 has brought in technology after technology. And I think some of you may be aware the Industry 4.0 has so many technologies. Okay, you have augmented reality, you have the digital twin, that is the simulation tools, or you have cloud, you have big data and analytics. So many things are there, in which of this is already in the mainstream. But in all these things, the additive manufacturing or the 3D printing, as we conventionally as we call it, the additive manufacturing is something which is really revolutionary, because this is something which you make things with. So this is the evolution of production technology, which is the opposite of a conventional methodology. I'm sure in the further discussions you will come across with very good examples how it is coming. In my personal experience, I would say, I mean, I've been in an industry where we wanted to produce things. And in today's world, we want to produce things. We want to get things in our hand very fast. It's like, so a traditional industrial development cycle used to take years, and the product physically from a design to a manufacturing, because you have to manufacture tools, so it will take months. So we are all used to that in the past. But today, the demand of customer is such that I want to see something tomorrow. And we have to make it happen. And this is where the additive manufacturing came in hand for us, because we were able to make prototypes. We were able to make, say, a physical product, maybe a scale model, or maybe something a life-size model, in a single day, over a day. Once you have it clear, that it can be put on the table or put on the display in front of the customer, saying this is what you wanted. So, and I have used it in industry to make such rapid prototypes or rapid visual, look and feel effect of the product. So this is what really appealed to me. Thanks. Yeah.
Thank you, Babu. Like, in fact, if you can, probably in the next questions, you can talk more about the passion towards this specific technology that we're talking about. Okay, so probably we can move to Irai or Franklin.
Yeah, so thank you so much, Mr. George. Thank you, the SICKI team, for organizing such a wonderful program. 3D printing. In 2015, when I was working for a company called JK Fenner, we are doing a disruptive technology, what is happening in next 10 years, where we want to invest. So people everywhere talking about the Industry 4.0. So Industry 4.0 means a lot of disruptive technology in Industry 4.0. So one of the technology which comes under Industry 4.0 is 3D printing. So in layman's language, they call it as 3D printing. Actually, the technical name for this industry is called as additive manufacturing. So when I went to the Formnext is the mega show for the additive manufacturing, which happens at Germany once in 2 years, where all the technology people place their technology, how the technology evaluation is happening, and next 4 years or next 3 years, what are the technologies are going to come. So when I step into that forum, we find out that it's not a 3D printing, it's additive manufacturing. So we call that mostly into the subtractive technology. You take a part, machine it, and then make a whole, whatever the desired shape. Or what we do, we make a sheet metal, put it in a press compound and make a fabrication component. But this, why it is additive, is just a simple layer by layer by layer, it was printing. When I went and watching the 3D printing, I thought it's just like a 2D printer. Whatever the documents you are taking, it's not like that. It's a 3D object is getting printed. That is why in a common man's language, a 3D object is getting printed by layer. So it's called as additive manufacturing. So 2019, I started my interest in additive manufacturing, then started doing research work. Then I joined in a startup company where they are into the service bureau for the additive manufacturing. Then slowly we understand then additive manufacturing is no more a prototyping, just like I want to take a toy and do it. It's much beyond. It's going for a functional requirement. So I think next, when we are discussing, we'll discuss about the applications, what and all we can do in additive manufacturing. So this is how I got into the additive manufacturing in common man language, 3D printing. Thank you.
Thanks, Franklin. Probably you also led us away that every 2 years, probably if people are interested, where to go. There it is. Germany is a place possibly every year. I don't know if it's happening in Germany, but then I think you're leading us to places, especially international areas where, these technologies are discussed, and probably people, students from different colleges can actually think of at least, and I'm sure that there could be some kind of probably a journal from such places as well, right? I'm sure that.
True.
All right.
True.
Thank you.
At the end of this thing, we can share some of the links also. People can follow up after this program.
Excellent. Thanks, Franklin. Okay, over to you, right?
Good evening, everyone, and I would like to thanks for the committee for the great opportunity. And I want to greet the students. I hear that there are 500 registrations. It's totally different. People are looking as what is new, what is learning. I don't know, about 10 years before we have this opportunity, we will not get this kind of exposure to get directly meeting the industrialist, what they are experimenting, what they are learning. And would say like 3D printing, probably we already aware and we already learned a little bit about 3D printing in the name of prototype. So it starts from the prototyping, but now it's nowadays it created a lot of application, not only in a specific mechanical, maybe automobile, aerospace, and all the application. I get introduced about 3D printing in 2010 when I got opportunity to do my master's in Anna University. And we heard about, okay, there is a new technology that gives option for your all creativity has been happen printed. You can achieve a lot of intricate structures and all, completely opposite to the conventional manufacturing. And would say like this technology will give you a physical model of what are the things that you want to develop in application wise, maybe what are the creativity that you want to do. It will make it happen as physical. Previously, it's not there. We have a lot of limitations in the manufacturing, maybe conventional. You could not able to create some structures. So it fails and it takes long time, as Balu sir mentioned. It takes months. Sometimes it takes years for us to see the physical model, whatever you are developing, designing. 3D printing make it is an hour, and it makes quick to see the physical output of what are the things developing in the different industry. I working in the healthcare field. I would like to share one experience where my complete mechanical mind changed into the medical way. I got an opportunity to assist one spine surgery in 2012. I never believed before as a mechanical engineer I can be in the operation theater. I can stand with the surgeon to little bit tell them this is what we designed virtually, and it changes the life of 8 years old girl. So this life-changing moment created, no, we should not work in a regular way. Like even in medical, there are a lot of software companies, you have to do that. At that time we break, okay, we want to work in a real application. That changes human life. That's how it started. Yes, 4-5 years of struggle. When I was entering into 3D printing, specifically healthcare, there is no awareness. So we created awareness. We are struggling. We are keep on struggling. Now it's a good stage to grow in a next level. Probably I'll give you some deep idea in per section. This is how I get know about 3D printing, and this is how 3D printing changed my life, to be frank.
Okay, 3D printing changes lives, and I can assure that. In fact, look at the kind of people, look at the panelists that we have, somebody who is like shaping lives, even extending lives of people. That is what is happening. So one of the things that, probably all the students might be looking at, one of the questions that you would want to know is, apart from the terminology called additive manufacturing, what is exactly 3D printing? That's one. And a little bit of history, if somebody can provide that, that would be really good. A little bit of history and geography, where it started first, and how did it start, and things like that. That would be a kind of a quick knowledge. That's it. If any one of you can share that. Anybody?
Ire, you are the right person for it.
Yes. Okay. Fine. Chuck Hull, he's a person who invented 3D printing in 1988.
Who's the person?
1985 something. Chuck Hull. So he is yes. So they developed the technology called SLA, stereolithography. Stereolithography is the first technology. It works on a liquid material. The same thing. It fill in a kind of maybe in a simple way. It's, you have to fill a liquid of water in a tank. And instead of, for example, if you're putting some freezer ice cubes like that, it will not freeze the whole body in a stretch. It will freeze the body in layer by layer, like a notebook. So it works in layer upon layer. The main advantage is specifically, since it's a layer and layer, this is not a subtractive. And main thing is, it will allow you to create intricate structure. That's the main advantage, I would say. Quick, as well as this is a complete advantage comparing to the conventional technology. And he is a MD of 3D system, and then a lot of people came, they invented stereolithography, and then EOS have their SLS technology. They come up with their multiple principles have their major role, and something they have patented process, something they want to do, everyone want to do. Like, for example, SLS has been patented by EOS for a long time. After the patent time, so a lot of companies, they come up with the SLS technology. And would say like 3D printing is not one technique. There are a lot of techniques, 4 or 5 techniques maybe we can be. Even I see some very old machine, you will not believe. It's say like a plastic layer based technology. You can see the plastic sheet. Okay, it will be spread over the bed, and that should be, instead of the injector or something, that should be a small knife kind of thing. It will cut, and it will place the glue and anti-glue liquids over there, and it will print over like our notebook. Okay, once you take it, you have to peel out the under-required region. That's the anti-glue. It will allow it to peel out, and you will get a solid model. So this is the craziest machine. This is a very old machine I have seen in 2010, and it's a basic machine. It has a lot of limitation. Now it's polymer, photopolymer, metal, and surprise ceramics. A lot of things are there.
Thank you, Irai. Thanks a lot for that.
Yes.
In fact, you led us to the next question in terms of the various materials that is being used in 3D printing. So that's something that you talked about. So in fact, when we had a discussion earlier as well, we were talking about it, that 3D printing is not just an engineering marvel. It has a lot of sciences involved in it. I'm talking about chemistry, engineering, computer science. You have to code. Do so many things that's involved in 3D printing. So for students who are here with us, for them to actually have a career in 3D printing, what are some of the things that they should be doing? Is there any kind of an advice from any one of you? Probably I'll start with Franklin and then move ahead. If others also can contribute, I would be happy to hear from each one of you as well.
Yeah, thank you. See, as you said that 3D printing, there are a variety of materials available. So we classify into metal, thermoplastics, and the elastomers. So in 3D printing industry, first part of the work is on the design conceptualization. That is, we need a designer. So whoever working on the design aspect, whether I know the CAD modeling, 3D modeling, or some kind of a simulation modeling, we need a basic designer to design a model which want to be printed. That's the first requirement. So any engineer who are into the design side can get into the 3D printing. Second version is something called design for additive manufacturing. Today, we manufacture product with the standard operating procedure of machining. But for a 3D printing, something called design for additive manufacturing. There are courses available for design for additive manufacturing. They call it as DFAM, D-F-A-M. So people who are doing that DFAM, they can get into this business. So that's one way of doing a course, extracurricular activity. Apart from their course, whatever they have in their college, they can also complete the design work, first the basic design, second DFAM. Third part of it, whatever you design, you need to print it. What form? So you need a material. There are wide range of materials. So material engineering, we call it as the material science. So who are into the material science? How aluminum will behave, how titanium will behave, how powder will behave, how the rare materials will behave. So all these material science people can get involved into the 3D printing. The fourth is simulation. How the 3D printing will print inside that closed chamber. What are the effects, stress analysis. So people can get into the simulation part of it. The next version is that as mechanical engineer is working with the healthcare. Irai is actually a mechanical engineer, but he works for healthcare. So this 3D printing bridge a gap between the common man, engineer, and the healthcare will work together to develop a ecosystem for a healthcare division. So there is something called biomedical engineers who can spend some kind of engineering knowledge and they can go into the healthcare 3D printing industry. So these are the segmental work. It's not that only one person can get into, nothing like that. A design engineer from a mechanical, civil engineering, any kind of architect. See, today 3D printing is used in automotive industry, aerospace industry, including the buildings are printed in 3D printing. So first thing, as my recommendation, design course, do that. Second, design for additive manufacturing. Third one is on the material science. Fourth is on the simulation part. And the fifth one is that you want to go into the biomedical side, do a biomedical engineering. Thank you so much.
Hey, thanks, Franklin. That was very, very crisp and clear about what students should be doing. Who knew that there is something called design for additive manufacturing? I mean, I didn't know about it. I'm happy to hear that. And also you talked about various verticals that probably 3D printing has applications to. And so there are various verticals, and then there are horizontals as well. We talked about various practices that you can be in, and so anybody who is in either horizontal or any of the verticals can be a part of this technology, is what you're saying. Excellent.
Oh.
So let me move a little bit in terms of like what we are in the digital transformation phase now. Most of the organizations that I have seen is talking about digital transformation. We're talking about digital leadership that we're going to develop. So this question is to Babu, wherein how do you see that 3D printing as a technology, or probably any such technology, how does it pave way to Industry 4.0? And what is your expertise in Industry 4.0? And probably you can talk about any other technology as well.
All right. Thank you. So a very good question. And as we look at as the technology is developing, as it unfolding. So as I told you in the beginning, this additive manufacturing is something which is a very disruptive technology, and it is one of the real physical things of the digital transformation. You know, all the other technologies are software. Okay, robotics is a bit of hardware, but something which is actually production technology is additive manufacturing in this. So we have all the existing manufacturing techniques, but with 3D printing, it's undergoing a radical reshift. So how does it, what is the impact or what is the implication of this? So as I said already, it reduces the cycle of the development cycle in a very, very large way. It is like in days. What could be done in months and years is becoming in days. So the limitation of a designer creating something and in the software and as a CAD and then going into the actual process, making mistakes in the process, because what is in the CAD versus what is produced through the conventional processes will always have differences. What you make in the design may not be manufacturable in a casting process. So again, you have to make changes. So with 3D printing, I think you're coming to a situation where you cut down a lot of the chaff of the design and the development process and come to making a product in a very rapid time. And it also cuts the accuracies, the inaccuracies and the iterations to a large extent. And therefore, in a few days, you can make a product, and obviously you can test it, you can validate it, and if necessary to make an iteration, it can be a very bare minimum set of an iteration to get to what you want as a product. So this is one, I would say, a phenomenal impact which is having. So in the digital transformation, this can be something which changes the scale of things by making something happen in an instant mode. Okay, and in alliance with the other technologies like the digital twinning technology or the cloud data or robotics itself for that matter, I would say it enhances leverages the power of a manufacturing firm or a IT firm in a large way, which is I think unprecedented. So this is what I would say is a very fundamental change which is coming when we are adopting 3D manufacturing, 3D printing and additive manufacturing.
Okay, thanks, Babu. You were talking about how 3D printing can help in reducing time in designing to production. Like, you know, that's exactly what you're. Yeah.
One more point, I think, yeah, as Irai mentioned, okay, the type of product which can be made in 3D printing is, I think, another big, I would say, I forgot to say that, but it is something which is radically and revolutionarily different because you can make intricate designs. I'm sure Franklin and Irai will show you some examples. These are unbelievably complicated products, and these are things which cannot be made in a conventional process unless it goes through a huge amount of pain. So making those kind of products is very much possible in 3D printing. And again, the caveat, it can be done in few hours and days. Okay. And I think as you hear from them, the examples, it is a phenomenal. It is even sometimes unbelievable to see this is happening right now. So that is another facet of 3D printing, which is really making a huge impact.
Excellent. Thank you, Babu. So intricate designs and the short time that 3D printers can help in producing in manufacturing, and that is pretty interesting. There are errors that human beings can make while designing and also while manufacturing, especially when it comes to deductive manufacturing. And we are talking about additive manufacturing where things are much more easier. Okay, all the students here, like, I request each one of you to also post if you have any questions, post your questions. We would take those questions and respond as well. Over to, probably, this question is to Irai, and sometimes I always feel like, when you have a technology like 3D printing in your hands, it is like playing God. You are playing a creator. You can create anything that you want. So the kind of applications, and the best person to ask on application would be Irai, because he's in the healthcare industry, and he is saving so many people, giving lives to many people in terms of, probably, I don't know probably he's the best person to talk about. In your industry, what are some of the applications? If there's any kind of instances that you wanted to mention, really exciting and wonderful experience that you have, that you've helped people using 3D printing, I would request you to share that story and incident. Thank you.
Sure, definitely. I would say, healthcare, it's completely different story. Before 3D, you can say it as a before 3D printing and after 3D printing. Because before 3D printing, of course, healthcare is in a diagnostic level. We have a CT scan, lot of advanced technologies, and I used to put one of a picture in my regular presentation. So you can also in Google it. You can see the operation theater 100 years before. Okay, you can see the operation theater currently in hospitals, maybe any hospitals. The difference is, okay, the surgeons are always expertise, Indian surgeons are more expertise, more experienced than other countries. And the only thing that they are striking it, where we can say about failures. Okay, I always prefer to talk about success. I prefer to talk about failures, because failures always take us to the next level. And the failure cases, few things are happening because of they are, would say, like they don't have that kind of assistance. Would say, okay, thanks for the word, like George said, saving life. We are helping surgeons to save the patient's life. Like in a small way, we are just assisting them. So we are just giving the access of for in detail, understanding. Like as the engineers, we know, we can't understand, we can't explain about the parameter by using a 2D photo. So we need a measurement, values and all, but doctors are operating a patient by using just a 2D photo. So that's what the difference. So 3D printing has changed everything from 2D to 3D. So they can see the patient anatomy externally, internally, what is the lesion, what is the problem they have, what is the fracture they have, each and every point they will feel, they will understand. I would say in a simple word, they know the result before entering into the theater. That's not happened before. Each operation theater, you'd say like it's a conference room, like what we are discussing. So they will put a patient and open the patient for the surgery. Then they will discuss about what we can do this, what we can, because they know the thing. So every surgery is a surprise. It's not a good surprise. It's a very shocking surprise for them. They thought something by using the CT, some diagnostic results. When they open it, they have complete surprise. They have to think, they have to do the thing. Sometimes they will not have that particular, some screws or plates or something there. But this technology make them to plan everything. Okay, before the surgery, they have a, for example, I can show you this model. So this is a patient model of the, we said it's a maxilla, upper phase of the thing. This may be a good example. Currently, you will not believe, after COVID, we have 25,000 cases has been waiting for surgery. Patients, 25,000 patients has been infected by mucor, that is black fungus. The only solution is they have to remove the whole bone where it is infected. Post-COVID effect. Okay, this kind of surgeries and planning has been planned well only by using 3D printing. And now the doctors are saying like 3D printing is the only solution for their normal life. There is no other option. So that's what in healthcare, as a mechanical, automobile or aerospace engineer or whatever may be the engineer, they have their own field and all. And also I would say one word, 3D printing has been in the different industry for a long time. And healthcare is a very, very fast growing industry. And I'd say like Franklins are well aware about it, how many cases they are printing, and it's keep on increasing. I would say like whenever we talk about new technology, we have to specifically understand the need. So without the need, there is nothing will happen, of course. And we should not put a technology where there is no need. So healthcare is a big industry, and I would say like there are a lot of opportunities for the engineers. It doesn't mean like mechanical engineer not to. There are opportunity. We are lagging of people. We don't have people. We are trying to recruit for a lot of people. But as Franklin sir mentioned, DFOM, design for additive manufacturing. And nowadays it's very easy for students. You can see a lot of videos in YouTubes and all. You can learn things. You can download journals, and would say like basic CAD. Knowledge is more important. Of course, we can learn things quickly. But healthcare, it's a big opportunity for the students as well as young engineers. And main thing is it's completely changing the procedure of healthcare. That's what I would say.
Excellent. Thank you so much. That was quite interesting, and thank you for showing the sample as well. I've heard somebody say, I think it was a blogger who said that stop being a consumer, start being a producer. I repeat,
Yes.
stop being a consumer, start being a producer. It's a good statement. Probably how long are you going to consume things? I think as a country, as a state, I think we should start producing manufacturing things as well. So I'm going to ask a question which is a little cheeky here. Just wanted to know, so some of you have experienced with 3D printers. One of the, a kind of a thought that I always had is what is the craziest, what is the naughtiest thing that you have printed on 3D printing machine? Anything that you wanted to say?
Yes, okay, maybe I tried printing some jewelry parts. It'll be surprising.
Okay.
Yeah, jewelry parts, and we printed when I was a student in Anna University, so we got some opportunity. We used to print some.
Where the jewelry was going to go?
No, jewelry is it's a big market. Jewelry is a big market, and you will not believe jewelry industry is the most utilizer of 3D printing technology.
See,
so I mean, like anything.
Yes. Irai is kind of humility personified. He's like when you say that he's changing lives and shaping lives and saving lives. He says that all credit goes to doctors and not him.
Yes, of course. Yes, yeah, yes. I would say it's reality, and the main thing is would say it's an interdisciplinary. It's not a one-man show here, so it's a complete interdisciplinary, and that's how the healthy field will grow. I believe that I got it from this word from few of the top surgeons. So they are people will very open. This as we will do this. So this is what your requirement. This is what a problem will do. And I would say I never tried much on craziest thing, but I tried one or two small models, mobile cases, and I tried craziest thing on my industry field. We always try to break, our joy of doing things is we gather problems from surgeons. We try to give some solutions. Sometimes it good success, it will be great. Sometimes it goes crazy. So we'll think also, okay, we do again. that's the experience.
Okay. So Babu, if I ask, what do you wish to actually produce or probably manufacture on a 3D printing machine or whatever? Probably in the future, being futuristic, what would you wish to actually manufacture?
I think, yeah, George, today, there are, I would say, as the applications are evolving, there is a lot of products. He mentioned jewelry, very interesting thing. Of course, the medical devices, this is all, happening. I think this is coming because the frontiers of this technology are being explored. And there is a lot of development going on in the materials to find materials which can make products. So I would say going future for a manufacturing or an engineering industry, we should be capable of making anything. Okay, as you have seen recently, there was the news that people could manufacture a house, a literal 3D printed house for a family to live in. Okay, excellent. So if this is something, this has already happened. So if this is something, it could revolutionize human life in such a way. You can actually print houses. You can make these fastly made houses and settlements for people to settle in places and make it in such a way that it can be very fast implemented. So in case of disaster relief or resettling people in some places, this could be the real solution. So if I were to look for applications like this and make it happen, so that housing for the poor or housing or such kind of facilities for disaster relief, this is something which I would really love to apply 3D printing in a very quick way.
Excellent. Yeah, okay. So probably, yeah, Franklin, I would want you to respond as well and probably show some of the
that's what I want
samples that you have as well.
Great, thank you. See, this is one of the craziest thing which we printed at Innos. This is
You
a
have to get closer to the camera. Yeah, that would be good. Yes.
so this is a skull model for me to keep as a pen stand. Okay, if I want to make this, we need to go for injection molding. Just made this printing and just keeping it on my table to keep it as for some kind of a healthcare or some pen stand. When we had one visitor, we were browsing about his LinkedIn. Then we saw that he went for a Eiffel Tower 2017 and he liked it very much. He's a customer. So when he was visiting, we thought that why not we gift him a Eiffel Tower? Where to go? He just printed. Just printed. Okay. Then when we had one engine customer, so he was coming, what to do, what are the things we can do? Just we printed this engine model. This is a 6-block engine, just a handy gift. Okay, so adding to a response to a question, the customized industry is going to play a major role. Whatever you want to do a customization, he said jewelry. You want to gift your wife a customized jewelry where nobody can do it, 3D print it. Or you want to do a customization, a lot of students are available here. They want to do something customized on their two-wheeler vehicle. They can design it, 3D print it. Or they want to gift something unique. Nobody has done it. They themselves design, print it, and make some kind of structures like this. A graphical representation. So all this, the customization industry will grow. That's where the healthcare industry, what he is working is the patient-specific implants. Earlier, we worked on implants, general implants, shoulder implant, hip implant, or whatever the spinal implants. But now we are working on the patient. For me, I want to replace this jaw. I can replace. Just take a CT and work out with the doctors, and I work with Irai. I hope Irai will give me a good design, lightweight design. So I can design it and we can fix it. All my cancer patients will get benefit out of it. No more a standard, just go to the operation theater, cut it and put it. Instead, make a specific to the patient and do a implant. So the customization is going to play a major role in all industry, whether it is aerospace industry or automotive industry or a healthcare industry or a jewelry industry or a, as he said that he want to go for a construction in 3D printing. It's possible. So the next is only the customization, no more mass production. As you go for this Rolls-Royce customization, you will have Maruti also will be a customization in 3D printing.
Excellent. Thank you, Franklin. In fact, one of the questions that I wanted to ask is more related to our country. If you look at India as a country, and when you compare to other countries, like where do we stand when it comes to some of these technologies, especially 3D printing? In terms, are we lagging behind, or are we leaping forward? What is your take on this? Who can respond to that?
I'm on marketing side, so I will take this question.
All right.
Okay. Okay, so see, in Asia Pacific market, see, in 3D printing industry, US and Europe are they are leading in this additive manufacturing. Last 15-10 years, they are into the production series kind of a thing. If you come to the Asia Pacific market, India is only giving 3 to 5% of the manufacturing in 3D printing. But there is a big scope for 3D printing manufacturing, specifically for the metal products. So market says that, one, take an example of recent war with Russia versus Ukraine. You need drones. Drones are 3D printed today. Today in India, government of India had localized all the banned China import of drones. So whatever drones you want to print, you can print it and it can go up to 400 feet height or 400 meters height. So that's the market is growing. Two, if you have a problem with Russia, all our aircrafts we have it from Russia. You need replacement of parts. You can replace the parts with the 3D printing.
We don't have problems with Russia.
We don't have problem. I'm just taking an example. If you at all have a problem, then we can 3D print something like that. So India as a market, you said, is a consumer market, now converting into a manufacturing market. So population wise, we are huge. In healthcare side, there is a very much high demand for 3D printing in healthcare, and on the automotive side, and all this customization is going to play a major role. So we are at a very, very starting stage of 3D printing. In next 5 years down the line, I hope in every street, like every home, you have a 2D printers, you will have a 3D printers in next 10 years down the line.
Okay, that's very, very nice. In fact,
and I would like to add one point in this.
Yeah, please, right.
I would like to add one point in this. Like Franklin sir said, Europe and people they are the leaders in this. They are the one who started first. And I heard from a lot of principals, OEMs from US and all. India is a very big market. Okay, they started first, and they will do the first kind of surgery of model surgeries. I'm talking about only healthcare. That's what I aware about. So the thing is model surgeries, implants and all. But always India will do it in a mass numbers. So India is always in a number game. So I would say like current situation, like reconstructive surgery, like patient specific implant, India is doing a lot of cases compared to all other countries. Okay, operating in a month. For example, in India, we are operating 15 to 20 patients in a month. This kind of surgeries. So India has a very big market in healthcare, and that's what people are very conscious in India are doing these things.
People are waiting. 25,000 cases are available. Now machine is not available. Surgeon is limited. Designer is limited.
Yes.
The market is huge. Only we need the young generation to come and join in this industry.
Excellent. That's a wonderful.
Maybe this is the product that everyone is looking for right now. The custom-made implant. You can see the metal implant. Probably is it visible? I guess. Probably I will show you the model also. So this is what a kind of case.
I think you have to remove your background, otherwise it's getting lost in the background.
Okay, one second. Change it.
Yeah, now I think we can see it. Yeah.
Yes. Can you see this?
Yes.
Yes. So this is a model. You can see here the implants. This is where most cases nowadays they are operating into the patients after things. So they will get a complete customized design implants. And this kind of structure will not be possible in any conventional technology. I would say in healthcare, this is a major difference, I would say.
Excellent. Thank you so much, Irai, for that. So sure. Franklin was saying, though Europe and America, they are leading in 3D printing. You're saying that, in healthcare industry, we do in great numbers is what you're saying. And also Franklin was also talking about the, he also has a marketing plan for, looks like that to me, marketing plan for 3D printing and design for. So have you forgotten your, probably a gift for Valentine's Day? Please join 3D printing, probably what some of the courses that you have.
Yes.
I think,
maybe in future they can design a customized, gift for proposals.
Yeah, you're right. Absolutely. And then you are, yes, Babu.
Yeah, I will add some number to what the gentleman said actually. So, it's always interesting to see in terms of growth of this market. So this industry, additive manufacturing industry, is growing globally at a 23% compounded annual growth rate. Okay. So, I mean, if you were to bet on money, you need to bet on such a growth. Second thing is a size, okay, from a USD, 7 billion size in 2017. What is the
percentage that you said, Babu? Sorry to interrupt.
23%.
23%. That's amazing growth.
Yeah. So, and the thing is, it's growing from, it was a 7 billion market size in 2017, and it's going to be 40 billion, close to 40 billion, maybe 35 to 40 billion in 2023. Okay. And as both Irai and Franklin were saying, there is a global tectonic shift. Okay. And I think the market for the people to look at is going to be in India. Up to now, the US and the European market have more than 50% of this additive manufacturing thing. But as you see, the defense sector or the healthcare sector, which is actually the most of the manufacturing sectors are the USPs from India, with Make in India or all these schemes. So definitely this is going to happen. And today we are a minuscule 1%. Okay, Asia Pacific is 28%, the remaining of what US and Europe does. And out of that, China and Japan dominate the entire Asia Pacific thing. India is a very small thing. So we are the ones who can actually, again, I think we can grow faster than this, even this 23% annual growth rate. We can probably grow 50 to 60% CAGR in this industry.
Okay, I have a question from the, I don't know if any one of you would be able to respond to this, because I don't see anybody in that industry, but still I'm just reading the question. It is from William Hazlitt. Any example of process industries, chemical engineering application, either for plant design or production? That's a question that William Hazlitt is asking. If you can respond, any one of you can respond to that. Any example of process industry, chemical engineering application, either for plant design or production?
Yeah, I think I can be able to take this. The process industry is really a big market today. That means you have steel processing, chemical processing, oil and gas industry. There are so many process industries are available. These industries are low in volume, so you cannot go for a standard tools and move forward. Or second, if something goes wrong on the machine, replacement of parts, they call in their language MRO, maintenance, replacement and overhauling, they call this. So in this particular segment, you want to have, say example, valve, closure of valve where a high pressure is there. You can 3D print that valve just like you are in a house. Just no need of storing any physical components, shifting any physical components. Something happens at the middle of the ocean in the oil drilling area, if some parts gone. As a soft copy, a designer from Chennai or designer from Madurai can send the parts to the oil rig area. If the printer is available, they can print. Today, printers are available with the chemical resistant material, low temperature material, high temperature material, including flame retardant material available. They can work on that and they can print it and they can use it in the process industry. That's one. Second, plant design. Today, to design any process industry plant, you make a 2D model, 3D model and showing it in a system. Or you want to make a model, a miniature kind of a thing, people used to cut the cardboard or used to cut a molding thing. Instead, you make a 3D product of a miniature and demonstrate your plant design. This is how I'm going to make a design. Any change you want to do, a design change, and easily you can do it at a minimum cost at a lesser time. Thank you.
Good. Thank you, Franklin. So you're talking about the process industry is a large market here, and also you get the kind of materials that we have, chemical resistance, high temperature resistance, and low temperature resistance. A lot of things that are, and I'm sure that these are required in any process industry as well.
Any process industry, yes.
Because of the machineries that are running as well, and the kind of materials that they use as well. Excellent. Okay, so one question, Babu was talking about Make in India. We can talk about do it yourself and things like that. So what is the cheapest printer that is available in terms of, like, if each one of us listening to all of you here, if each one of you want to actually lay hands on a 3D printing machine and also learn from that, probably where should they go? What would you advise to actually, get out? You can give your advice here as well.
You want to give?
The cheapest, probably affordable, cheapest.
Should be understanding 15.
As a cheapest should be the word affordable.
15,000.
15,000 rupees.
You can buy as a machine. And nowadays, I hear a lot of engineers, student projects, they are build their printers. They are buying some spare parts like separator. they are developing. The cheapest should be 15,000, I guess.
Okay.
I know, 15,000. And they can print. To learn the technology, it's enough. Can do a lot of things.
Okay. And what would be the running cost of? Is it buying cost of 3D printing is higher, or running cost of 3D printing, the operations cost, in terms of the materials and other things that we need to buy, maintenance and things like that? What do you think?
Industrial grade printers, industrial grade printers say this end user functional part, what we are talking about, the process industry parts can all to be made. Then it is a captive intensive products. The machines are in 10 crores, 15 crores, 20 crores kind of a thing. So the first initial capital will be very high because products are produced in a material called titanium, aluminum, Inconel used for space requirement. Recently, the Chennai startup Agnicool, the entire engine is 3D printed, which is the Inconel and titanium materials, where the 3D printer cost is high. And your consumables called the raw materials also, subsequently the cost is high. For a student to run it, it's affordable, 10,000 rupees or 15,000 rupees, they can buy it. If they are not able to get a hands-on experience, they are not able to do it, they can approach us, me and Irai. We can able to help them to give some models and other things they can work for their projects.
Oh wow, that's a good. Those who are here listening to Franklin and Irai, I'm sure that you would be sending a lot of mails and probably calls would be landing upon. I don't know if there are coordinates here, but I'm sure that it can be done through SICI, South Indian Chamber of Commerce, as well. Okay, Franklin, you showed us a kind of some of the applications of 3D printing that you have come. The presentations are there in terms of automotives, in terms of aeronautics and things like that. So what are some of the I would say high value applications using 3D printers? If you can actually show some of your presentation that you have.
Yeah, it's now visible.
Yes.
Yeah.
So this is about our company name. Okay. Now, 3D printing for aircraft interiors. A lot of people were traveling in aircraft. A lot of people doesn't know that some of the components can be 3D printed. You are seeing the topmost cabin. When you are landing at Chennai, if cabin door gets break, you have to wait physically, the door has to come. But in today's time, only you need a model file and you can 3D print and you can fix the problem there itself. Interior. See the kind of parts can be printed in an aircraft. Whatever you see, the line marks, including the electrical housing. The electrical housing you required the electrostatic discharge material, ESD material. There also you have a 3D printed materials where you can use ABS with the ESD material can be used there. Here the plastics are being used where the flame resistant material, if anything happens inside the aircraft, the flame should be retarded kind of a material is available. These are the aircraft interiors. Where you sit, the shroud or the vent or a camera cover or internal door latches can be 3D printed. So these and all we physically see in the aircrafts, including the air ducts, seat covers. Today, the commercial material grade is available which can be used for the end use applications. Wall panels, if you sit on the side, you have the window. On the window wall panel can be 3D printed. Material is available. We have this facility at our end. Automotive industry. In 20 years before, a new car has to come, it takes minimum 5 to 8 years new product development time. Today, new product development time is 3 years. Why? Your concepts are 3D printed. Once the concept is 3D printed, the design validation also done as a 3D printer. See the design picture of the second one. The model grid printed and they seen it. Or else you have to wait for 6 months time to make this mold tool. And functional frames of a two-wheeler. All this design, the last column where you see, this is the integrity of the customized one. You can able to print it and you can go forward. Front grills, air ducts, including your fixtures. To fix your wind glass, you need a metal one to fix it. But today, the metal ones are replaced with a plastic lightweight. Just fix it like this. Aerospace component, see the impellers, see the manifold with this kind of design. You need at least 7 stages of conventional manufacturing to print this exhaust. But today, it is printed in one unit. Drone industry. Drones, lot of drones is 3D printed. There is no mass kind of a one single design. According to your payload, what kind of duration it should fly, what kind of capacity it should imagine, all these are being used in the 3D printing. In a nutshell, ability to manufacture the complex part. Wherever you have a structure, welding problem you have, or you cannot do some kind of a 2-3 part integration, you have a problem, you can go forward for a complex part. Reduce time to market. Earlier, 8 years for a car coming. Today, 2.5 years, new models are just coming at this. Reduced cost of manufacturing. Risk mitigation. Once you develop a tool, you want to change it, the entire tool cost go away. So risk mitigation is happening. Reduction of number of parts and print on demand. No need to physically ship parts from X place to another place. You have only digital inventory. Have a, like your phone, how you have your photos, have your design in your system. Print it anywhere. Your logistics cost will get saved. Your time will get saved. Thank you.
Thanks a lot, Franklin. That was a very quick presentation, and probably it was quite interesting as well. The application, the extent of application of 3D printers in all areas, especially aeronautics, automotive, drone manufacturing. That was pretty interesting as well. I am sure that is the future. So talking about the future, just one more question, where do what do you see in the future, especially, where do you think that this 3D printing technology is going to go? What is your kind of a forecast that you see especially in India and for the students here? Any kind of thoughts there in terms of where do you see in the future?
See, all we are talking about 3D printing, the next thing is come as 4D printing. I think, Ira, you just add that 4D printing will have that's the future.
What is 4D printing?
Yes, probably Franklin sir. You please explain.
Okay. 4D printing is whatever you produce. This is 3-dimensional one. The fourth one is having that it will, for a time period, it will be like this structure. Slowly it will change according to the time frame moves up.
Okay.
That's the 4D printing, which is currently used in healthcare industry.
Okay. So probably,
okay,
have you used some of those sometime in the past, or 4D printing?
No, not yet. So it's in a research level. So maybe we are not using it in healthcare. Maybe in a future, would say, like, as of now, we are working on metal. We are trying to giving some implants, maybe the substitute of our bone, but it's a different material. Obviously, we have to accept it. Metal, it's compatible. It's not a real bone, but maybe you will see it's in the future. Of course, healthcare have a long way, and now currently we also started using ceramics. Ceramics in the sense healthcare. Maybe a few people may know about hydroxyapatite, tricalcium phosphate. These are the material. These are the exact bone material. So this things, metal will be a substitute, but this material will act like a bone. So it will be a same chemistry of the bone. So this may be it's not a future, it's currently happening. And would say, like, in a future, it's very surprising things. Now bioprinting is there. So you don't want to, yes, bioprinting is there, that you don't want to do animal studies no more. For any material or any drugs, when you develop, we have to test in a laboratory. So I have experience on testing in the laboratory, and I have few participated in few animal studies also. It's very hard. okay, it's very hard to implement test. We have to do a lot of trials on that. But now bioprinting is totally changed. You don't want to do the animal test, and this bioprinting is more than animal test. But take a simple layman word. There are some material. That material, you can 3D print the material in some shape, whatever the shape you want. But that shape, material along with the part will react like your human organ. For example, if you want a heart, it will be, it's not a real heart. You can't implant into you can't put into the patient, but it will be react like nature. For example, if I'm putting some drug, some medicines, it will react like a human heart. So you don't want to do the animal study. So that's what the current status. Yes, we are working with a company called 3D system based. Alivi is a one printer, and there are a lot of printers in the market. Materials. That's a bio ink, they said. But in future, it's a organ printing. That's what the all research is going on. Even I'm also participating in few activities on that. Scaffold is build the organ in the same shape, and next is organ printing. That's maybe would say like maybe the ultimate goal for the whole 3D printing some healthcare industries. So
including sorry,
yeah, go ahead,
yes.
sorry, Franklin.
Including 3D printed foods going to come in another 10 years time. Already researchers are there. One of the research, they have done it for 65 years to 75 years old people they have taken. Old age people require a multicolor food, but they cannot eat more food, but they need only a limited food. So they are creating a multicolor food with the required nutrition in it, so that they will take it as a tablet, or they will take it as a small packet of this thing. Research already some 30 kind of a people they have done it. Research is going with some results. So hopefully by another maximum 5 years down the line, a 3D printed food will be available.
So and one more thing, the medicines. Sorry to in medicines. So if you have some problem, you are taking BP, sugar, and all tablets. You don't need to take 10 tablets. So they will create a customized tablet for your dosages. So one tablet will give you all solutions. So that's the pharma industry already there. They started their activities on it.
This is really exciting. It's not 3D, and it's in future it's going to be 4D, and the kind of things that you're talking about, that especially in the healthcare industry, you're going to print food very soon. You're going to have single dosage, multi-medicines in one thing, through 3D printing. Excellent to hear all these things. So Babu, I'm a little worried here, like, I don't know, technology is a boon or a bane, but one thing that I see is, are humans going to become a little immortal? Are we going to, create organs and probably live for the rest of our lives? I really don't know. I don't know it's a good thing or a bad thing, but yeah, here I have a question from Sham, and I think it is about automotive. So he asked, additive manufacturing will be helpful in the automotive field as there is a lot of mass production. The question is, how will additive manufacturing be helpful in the automotive field as there is a lot of mass production? It needs less mean time. Injection molding is more faster. Is it, am I right? How will additive manufacturing overcome this? That's the question.
I think very intelligent question. So as on today, additive manufacturing is not for mass production. The cost is not a viable solution for mass production, but there is always a solution for it. Today, injection molding, if you want to machine injection molding a tool, it will take 3 months to 6 months time. Instead, you go for machining the injection molding tool, you 3D print the tool so that you will get a less time, so that your injection molding tool can be ready. One. Part that can be used for an injection process and for a mass production at a least cost. 2. Injection molding requires the faster cooling channels. See, injection molding will inject, there will be a temperature escalation will happen. So that the cooling channels today, you call it as a jet cooling channel, you can go only with a 1 mm diameter, and it will not go through say if you have a L angle, it will not go through the L, it will go on the wall of the periphery tool. So your cooling channel in the process will be always high. Today they call it as a conformal cooling in the injection molding. So you can go through your cooling channel along with the product line in the injection tool. So your tool life will increase, your cycle time will get reduced, your productivity will go up. So 3D printing can be used in a indirect method of going in the mass production in tools and fixtures, where the conformal cooling can be used in the fixture. Second, tool itself can be printed in the 3D printing metal, like D2 material can be printed and we can use it.
Okay. Thank you. So we have been talking about this is more towards digital transformation, and the era is that is. I mean, I think I mentioned this earlier as well. In fact, there is a question as well from Sriram. It says that, is there any suggestion to work on projects on the recent trends of 3D printing? Yeah, I think if anybody can take that question, is there any suggestion to work projects, especially some of the projects that is there on recent trends of 3D printing? Who can probably, Babu, if you can help in this in terms of like, because, you know, we're talking about industries, we're talking about what are some of the industries that can help in this, like, you know, if students want to do internship and if they are interested in 3D printing, what could be some of the avenues that students can choose?
Okay, thanks. I think there would be, I would say I can think of two ways of answering this question. One is, you know, to build up what these gentlemen have said, there is you know, huge scope in several industries, and there are several industries still not even I would say explored yet, because I think it's like in the list of things to come. One thing, as we all saw, there is a time frame, there is a very rapid turnover of design to actual product, which is the future of which is due to the additive manufacturing thing. So what I think this and what we have seen, we can use this concept 3D printing for any industry to crystallize something from a design phase to a real product phase. So if any innovative startups, they want to use something, they want to create a product concept, I think very easily they can use 3D printing, and it is available. It's not that you have to buy the machine, but it's available as a service from companies such as these gentlemen have, where you can conceive a product, you can actually take their assistance, or you can design it yourself, and you can actually get the product made. Okay, be it, I have heard that people are using 3D printing for, as they have seen all the examples, but it's also being used in agri-tech. It can be used in you know, urban housing design, or it can be used in engines as well. Okay, so this is one thing which you can easily find applications and use 3D printing for your innovative startups. Okay, if you want to develop something new, and you know, conventionally you're bound by, oh, this cannot be made in casting, this cannot be made in fabrication. I think we can go to 3D printing to find the right material and then make it. Okay, the solutions are there in the 3D printing process.
Well, that was, thank you, Babu. Okay, Hirai wants to say something.
Can I add on? Yes. Okay. Since they are asking the project, probably I would like to say, like as mentioned by Franklin sir, in 3D printing, softwares takes a very major role, and probably people will aware about the RE, reverse engineering. So anything that related to reverse engineering, you can implement in the 3D printing process, not only in healthcare, any industries. So any complicated part, any delicate things, some failures, you can scan it, you can take it as a digital file, you can redesign, redirect it, and you can make a prototype, you can validate. If it is a mass production, you can convert as a regular industrial print. If it is a customized production, you can go stick with the 3D printing itself. Reverse engineering is because 3D printing is not only the printing. So it's a kind of oven. It's going to make your preparing any things. But before that, let's say like pre-processing, post-processing. The pre-processing involves of design, idea, innovation, creativity, and understanding of deform and all. So softwares takes a major role. Maybe CAD softwares, it's a basic, and based on each industry, there are different softwares. analysis and all that. So that reverse engineering is major into the any kind of projects or new product development, anything. Probably it's a small.
All right, Franklin wants to say something. Yeah, go ahead.
Regarding, I think already touched about the one is we talked about the design for additive. Second, he talked about the reverse engineering. Third, I want just to add one more, the term called topology optimization. So 3D printing required the topology optimization. Say example, you want to print a structure. Olden days you printed through, olden day you manufacture through casting. So a lot of material will be used in that structure. So the topology optimization is a concept or a software is available today. The same application, say 2 tons of load is required. How much material is required? Whether you need to print it straight line with a lot of boxes in it, so that the pillar will be a 1 kg earlier. Now it will be only 200 grams. With the 200 grams, the same 1 ton material can be lifted. So that's called as topology optimization. That is same function with a less number of material, so that today's environment, the carbon footprint can be less. So whoever want to do a project, they can work on topology optimization also. Take any conventional product, try to work on the topology optimization. Today's software called topology itself is one software available. They can try to use, the students can use that, some free version is available. They can try to convert any one of from their lab, take any load bar, try to put it, try to convert the design. Interesting, fabulous design will come. Thank you.
Thanks, Franklin. In fact, the glamour towards IT, information technology, is high these days, and people really want to move to information technology. And one of the streams that colleges are getting filled is also computer science and information technology. But this seems to be more kind of a combination of core and various things. I mean, I don't know whether if I'm right in saying that. So probably this is my final question. I mean, I don't know if there are more questions from the students, we can take that. Probably this is my final question, and I think each one of you can take a few minutes and respond. What is your advice to students, especially who was willing and probably was aspiring to be in the core industry, and probably would you suggest 3D printing as one of a viable career option?
Probably we'll start with Balas.
Okay. I think it's very clearly a futuristic technology concept. So you should be into this right now when it is evolving. As you have seen, considerable things have already started. So it's the right point of time to get into such technologies, like other path-breaking technologies, but 3D printing is really going to grow. So you have enough of applications yet to come. I think be it healthcare, be it automotive, or be it aerospace, even some things which are not yet thought about. Actually, they mentioned very interesting things about the 3D printed food. There are people who are working on sustainability side of it, using recyclable plastics to make 3D printed products. So basically, this could be something breakthrough if you can make products by recycling the original product and again remake something. If this can happen, this is something also, I would say, something close to a circular concept on this. So in many of these ways, I think definitely knowing 3D printing or having 3D printing as one of your skills is definitely going to be equipping you for the future. I think there is definitely very high growth you can expect in this.
Thanks, Babu. So what you're saying is strike the iron when it's hot, and this is the future. Probably there could be so many avenues, and you never know in what is in store for you. This is what you're saying. It's what you're saying is right in terms of technology. I mean, at least when I see it, I mean, I was saying that the kind of awe that I had when you saw your normal pen printer, and right now we are making things, and in the future there are so many things that we are yet to see, and it could happen as well. So I think it's a right place to go. Thanks, Babu.
Thank you.
I think from my side, definitely 3D printing is a disruptive technology. There are so many things are coming. Data science is there. A lot more workings are going on the IoT front. Automation is happening. So industry is actually going into a different parameter. Earlier, it was only mechanical, civil, electrical, and then it converted into a mechatronics, EEE, then EC, EI, instrumentation, all these subcomponents started coming. So today, no more common generic thing. People want specialists. A doctor is no more today is a general doctor. Doctors, you have heart surgeons, you have a maxillofacial surgeon. So like that, there are specialists are coming up. So my request or what I see as this thing, study your basic understanding of engineering, whatever engineering you are doing, whether it's mechanical, civil, or whatever it is, add a extracurricular, say, on the 3D printing side. Do a 3D printing course, do a design course. Then you will have your own base engineering understanding added to the disruptive technology to your portfolio. So you will become a specialist wherever you go. You will get a job in Airbus, say example. You will get for your design. When you have an additive understanding, an added advantage of a 3D printing or added advantage of a data science, you will go into the disruptive technology group, provided you will not in the common group. So my request, do additional extra course in design for additive or simulation or reverse engineering or this topology optimization or healthcare related, hospital management related course as an added package to your existing business, what you do, existing career. Definitely 3D printing is going to have a massive structural change in the way you look at products. Thank you.
Thanks, Franklin. So your suggestion is to take up another course, like probably an additive kind of a extracurricular stuff.
Yes.
In terms of, it could be anything like design. It could be the topology optimization. But I mean, those words are very new to me, and thank you for letting me know those words. I'm quite happy to learn those things as well. So probably I'll also go and Google and understand what those things are. I'm quite excited to know more about it. Thank you, Franklin.
Thank you.
Yeah.
Thank you.
Yes.
So over to you, right?
Yes. In general, 3D printing would say like it's a future. It's a future, and it's not a currently we are using for I would say like not all application. The application that we are using, that we are trying, is very minimal. It has more than that, and would say as a engineers, as a technology people, so I would say like basically whenever student, I would say like find a problem, so try to resolve it, try to find a solution how we can go with it, and that's how 3D printing will always help us. It's not a dream and it's not a toy, and it's a technology that will give you physics of all your creativity. So there is no limitations on your creativity. That we have to just think on what is practically possible and what is the limitations and barriers on the where we are implementing and all. And with respect to healthcare, of course, we are, and a lot of peoples, in India, maybe other countries, they are trying to solve a lot of solutions for their complexities, struggles of doctors facing it. Whenever students are doing their PhDs and any project, when we are in touch, we tell them, please find a problem. That's what the ultimate thing. Even any industries, find a problem, we can easily give a solution. It is a complicated, is a single, or I won't say it's going to change the all manufacturing thing, as they mentioned, like bulk manufacturing, the mass numbers is totally different. So it's not an entire solution for all the manufacturing field. So we have to understand, we have to apply in the right place. Then it will be cost effective, and it will be a value for the technology. And would say like we can't predict the future, but now by 3D printing you can make the future.
Excellent. Thank you.
So
Thank
that's
you.
the reality. That's the reality we have to accept it. Yeah. Thank you so much.
Thanks a lot. In fact, there are no limitations to creativity. I'm sure that there could be limitations to 3D printing, like you said, not in all processes, not in all manufacturing it can be used. But I'm sure that, there's an amazing career in 3D printing. And I think like what Irai said, creativity is what it is. I also heard somebody say the hardest task for a human being is to think. The hardest task for a human being is to think. And I think it is important to keep creating, generating new ideas, and definitely 3D printing is going to help us in all those areas. You think of a product, I think you can make it, and that's what it is. Thank you all, and it was an amazing discussion. And for me, I was looking forward to it, and I really learned a lot of stuff. I have learned a lot of things personally about various concepts and ideas and also applications of 3D printing as well. Thank you, Franklin. Thank you, Babu. Thank you, Irai. Thank you so much for being
Thank you so much.
Wonderful panel members.
Thank you.
Really, you're the brilliant minds as of now, probably, and I'm sure that there are many students who are listening also would agree to this. And I'm sure that you would be bombarded with a lot of questions and things like that in the future. Thank you so much.
A lot of brilliant minds were hearing the conversation. I hope that we can spark more brilliance than even what I could humbly contribute. I think we should see a lot more brilliant minds coming up. Yeah.
Definitely, yes, and that's the idea as well, and that's what we all are hoping and looking forward to. Thank you so much, Babu.
Yeah, thank you so much.
Thanks a lot.
Yes.
William, over to William.
Yes, sir. Yeah, thank you so much, sir. On behalf of SICI and SVC College, we would like to thank Mr. George Koshi, who moderated the session today, and also 3 experts who were in the panel giving their inputs to the students who were very active. And this is the first session we had today, which went on well successfully on additive manufacturing 3D printing. Followed by actually months, we have the other sessions also coming up. We request the students to kindly participate. And further, if you want to know more about the SICI events, you can also log into. You can check SICI's website, sicci.in, for further details. Thank you so much, sir, and thank you all the participants for your patience and listening to us. Thank you so much.
Thank you, William.
Thank you, one and all. Thank you, everyone. Thank you.
Thank you all. Thank you.
Thank you.
Thank you, Vinod. Thank you, William. Thank you, George. Nicely done.
Thanks.
Thank you.
Thank you.
Thank you. Bye.
Sure. Thank you, everyone. Yeah, bye.
Thank you. Bye.